What is the most exciting or some of the most exciting things that you see in the future impact of Neuralink, both on the science, the engineering, and societal broad impact?
So Neuralink, I think, at first will solve a lot of brain-related diseases. So it could be anything from like autism, schizophrenia, memory loss. Like everyone experiences memory loss at a certain point in age. Parents can't remember their kids' names and that kind of thing. So there's, I think, a tremendous amount of good that Neuralink can do in solving critical damage to the brain or the spinal cord. There's a lot that can be done to improve quality of life of individuals, and those will be steps along the way. And then ultimately, it's intended to address the existential risk associated with digital superintelligence. Like we will not be able to be smarter than a digital supercomputer. So therefore, if you cannot beat them, join them. And at least we want to have that option.
So you have hope that Neuralink will be able to be a kind of connection to allow us to merge, to ride the wave of the improving AI systems.
I think the chance is above 0%.
So it's non-zero.
Yes.
There's a chance. And that's...
so have you seen Dumb and Dumber?
Yes.
So I'm saying there's a chance.
You're saying 1 in a billion or 1 in a million, whatever it was in Dumb and Dumber.
You know, it went from maybe 1 in a million to improving. Maybe it'll be 1 in 1,000, and then 1 in 100, then 1 in 10. It depends on the rate of improvement of Neuralink and how fast we're able to make progress, you know.
Well, I've talked to a few folks here that are quite brilliant engineers, so I'm excited.
Yeah, I think it's like fundamentally good, giving somebody back full motor control after they've had a spinal cord injury, restoring brain functionality after a stroke, solving debilitating genetically oriented brain diseases. These are all incredibly great, I think. And in order to do these, you have to be able to interface with the neurons at a detailed level, and you need to be able to fire the right neurons, read the right neurons, and then effectively you can create a circuit, replace what's broken with silicon, and essentially fill in the missing functionality. And then over time, we can develop a tertiary layer. So if like the limbic system is the primary layer, then the cortex is like the second layer. And as I said, obviously the cortex is vastly more intelligent than the limbic system, but people generally like the fact that they have a limbic system and a cortex. I haven't met anyone who wants to delete either one of them. So they're like, okay, I'll keep them both. That's cool.
The limbic system's kind of fun.
That's where the fun is. Yep, absolutely. And then people generally don't want to lose the cortex either. Right, so they like having the cortex and the limbic system.
Yeah.
And then there's a tertiary layer, which will be digital superintelligence. And I think there's room for optimism, given that the cortex, the cortex is very intelligent and the limbic system is not, and yet they work together well. Perhaps there can be a tertiary layer where digital superintelligence lies, and that will be vastly more intelligent than the cortex, but still coexist peacefully and in a benign manner with the cortex and limbic system.
That's a super exciting future, both on the low-level engineering that I saw is being done here and the actual possibility in the next few decades.
It's important that Neuralink solve this problem sooner rather than later, because the point at which we have digital superintelligence, that's when we pass the singularity, and things become just very uncertain. It doesn't mean that they're necessarily bad or good, but the point at which we pass the singularity, things become extremely unstable. So we want to have a human-brain interface before the singularity, or at least not long after it, to minimize existential risk for humanity and consciousness as we know it.
So, but there's a lot of fascinating actual engineering, low-level problems here at Neuralink that are quite exciting. What
the problems that we face in Neuralink are material science, electrical engineering, software, mechanical engineering, microfabrication. It's a bunch of engineering disciplines, essentially. That's what it comes down to, is that you have to have a tiny electrode. It's so small it doesn't hurt neurons, but it's got to last for as long as a person. So it's got to last for decades. And then you've got to take that signal, you've got to process that signal locally at low power. So we need a lot of chip design engineers that are, because we've got to do signal processing and do so in a very power efficient way so that we don't heat your brain up, because the brain's very heat sensitive. And then we've got to take those signals and we've got to do something with them, and then we've got to stimulate the back to so you could bidirectional communication. So if somebody's good at material science, software, mechanical engineering, electrical engineering, chip design, microfabrication, those are the things we need to work on. We need to be good at material science so that we can have tiny electrodes that last a long time. And it's a tough thing with the material science problem. It's a tough one because you're trying to read and simulate electrically in an electrically active area. Your brain is very electrically active and electrochemically active. So how do you have, say, a coating on the electrode that doesn't dissolve over time and is safe in the brain? This is a very hard problem. And then how do you collect those signals in a way that is most efficient? Because you really just have very tiny amounts of power to process those signals. And then we need to automate the whole thing so it's like LASIK. So it's not. If this is done by neurosurgeons, there's no way it can scale to large numbers of people, and it needs to scale to large numbers of people because I think ultimately we want the future to be determined by a large number of humans.
Do you think that this has a chance to revolutionize surgery, period? So neurosurgery and surgery all across?
Yeah, for sure. It's got to be like LASIK. Like if LASIK had to be done by hand by a person, that wouldn't be great. Yeah. So it's done by a robot. And the ophthalmologist kind of just needs to make sure your head's in the right position, and then they can just press a button and go.